The National Electrical Code Section 250.64e addresses the installation requirements for the grounding electrode conductor, often abbreviated as GEC. This section provides specific guidelines on where the GEC can and cannot be run in relation to other conductors in an electrical system. The core principle to understand is that while the GEC is permitted to be installed alongside circuit conductors in the same raceway, cable, or armor, there is a crucial exception. The grounding electrode conductor cannot be installed in the same raceway, cable, or armor as grounded service entrance conductors. To fully grasp this rule, it is essential to define a few key terms. Firstly, the grounding electrode conductor is the conductor that connects the service equipment, or the separately derived system, to the grounding electrode. The grounding electrode is typically a ground rod, a metal underground water pipe, or other approved grounding means. Secondly, service entrance conductors are the conductors that run from the serving utilities transformer to the service equipment. This is where the main power enters the building. Lastly, grounded conductors are conductors that are intentionally connected to ground. In a typical electrical system, the neutral conductor is a grounded conductor. The rationale behind not allowing the grounding electrode conductor to be installed in the same raceway as grounded service entrance conductors is to prevent unwanted circulating currents in the grounding electrode conductor. When the grounding electrode conductor is run in parallel with grounded service entrance conductors, a portion of the neutral current can return to the source via the grounding electrode conductor and the grounding electrode. This can cause several problems. Firstly, it can cause the grounding electrode conductor to become energized, which can be a safety hazard. Secondly, it can cause inaccurate readings on ground fault detection equipment. Thirdly, it can contribute to electromagnetic interference. Now let's break down why this separation is so critical. The grounded service entrance conductors, typically the neutral, carry the imbalance of current from the phase conductors back to the source. When the grounding electrode conductor is placed in close proximity within the same raceway as these grounded conductors, a phenomenon called inductive coupling occurs. Inductive coupling is when a changing magnetic field produced by one conductor induces a current in a nearby conductor. In this case, the alternating current flowing through the grounded service entrance conductors creates a magnetic field that can induce a current in the grounding electrode conductor. This induced current on the grounding electrode conductor can lead to several undesirable consequences. Firstly, it can cause the grounding electrode conductor to carry current that it is not intended to carry. The grounding electrode conductor's primary purpose is to provide a path for fault current to return to the source, allowing overcurrent protective devices to trip and clear the fault. When the grounding electrode conductor is carrying normal neutral current, it reduces its capacity to effectively handle fault currents. Secondly, the induced current can interfere with sensitive electronic equipment. The grounding electrode conductor is intended to provide a stable reference point for electronic equipment. When it is carrying extraneous current, it can introduce noise and interference into the system. Thirdly, the circulating current can cause corrosion of metallic components in the grounding system. The unwanted current flow can accelerate the electrochemical process that leads to corrosion. The NEC recognizes these potential problems and, therefore, mandates the separation of the grounding electrode conductor from grounded service entrance conductors. This separation minimizes inductive coupling and ensures that the grounding electrode conductor performs its intended function of providing a lower impedance path for fault current. It is important to note that this rule does not prohibit the grounding electrode conductor from being installed in the same raceway as ungrounded service entrance conductors, which are the phase conductors. The phase conductors do not carry a continuous return current like the neutral, so the inductive coupling effect is significantly reduced. To comply with NEC 250.64e, the grounding electrode conductor must be installed in a separate raceway, cable, or armor from the grounded service entrance conductors. This can be achieved in several ways. Firstly, the grounding electrode conductor can be run as an exposed conductor, meaning it is not enclosed in a raceway or cable. However, if the grounding electrode conductor is exposed to physical damage, it must be protected by a suitable enclosure. Secondly, the grounding electrode conductor can be installed in a separate metal or non-metallic raceway. If a metal raceway is used, it must be bonded to the grounding electrode conductor at both ends to provide electrical continuity. Thirdly, the grounding electrode conductor can be installed in a cable assembly that is separate from the service entrance conductors. Let's consider some practical examples. Imagine a scenario where a building has a 480/277 volt, 3-phase, 4-wire service. The service entrance conductors consist of 3 500 kcmil copper conductors for the phase conductors and one 500 kcmil copper conductor for the neutral. The grounding electrode conductor is a number 2 copper conductor. In this case, the number 2 copper grounding electrode conductor cannot be run in the same conduit as the 3 500 kcmil phase conductors and the 500 kcmil neutral conductor. It must be run in a separate conduit, or it can be run exposed, provided it is protected from physical damage. Another example is a situation where a building has a 208/120 volt, 3-phase, 4-wire service. The service entrance conductors are run in a cable tray. The grounding electrode conductor cannot be bundled together with the service entrance conductors in the cable tray. It must be routed separately, either in a conduit attached to the cable tray or by some other approved means. It is important to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Improper installation of the grounding electrode conductor can create a dangerous situation and can lead to equipment damage or personal injury. Now let's delve deeper into the specific requirements outlined in NEC 250.64e. The section is titled Installation to Electrode. Subsection 1 addresses the aluminum or copper-clad aluminum grounding electrode conductors. It specifies that aluminum or copper-clad aluminum grounding electrode conductors shall not be used where in direct contact with masonry or earth or where subject to corrosive conditions. Subsection 2 covers the continuity of the grounding electrode conductor. It states that the grounding electrode conductor shall be continuous from the service equipment or source of a separately derived system to the grounding electrode. Splices are only permitted under specific conditions, such as irreversible compression type connectors listed as grounding and bonding equipment or by the exothermic welding process. Subsection 3 addresses the protection from physical damage. It requires that grounding electrode conductors be securely fastened to the surface on which they are carried. A number 4 or larger copper or aluminum grounding electrode conductor shall be protected if exposed to physical damage. A number 6 copper grounding electrode conductor shall be protected if exposed to physical damage. Smaller than a number 6 grounding electrode conductor shall be in rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, electrical metallic tubing, or cable armor. Subsection 4 discusses the installation of the grounding electrode conductor for alternating current systems. It provides more detailed rules for the routing and protection of the grounding electrode conductor in various scenarios. This subsection includes the rule prohibiting the grounding electrode conductor from being installed in the same raceway as grounded service entrance conductors. Understanding and adhering to these requirements is critical for ensuring a safe and effective grounding system. A properly installed grounding system provides a low impedance path for fault current, which helps to protect people and equipment from electrical shock and damage. In summary, the grounding electrode conductor plays a vital role in electrical safety by providing a path for fault current to return to the source. NEC 250.64e specifically prohibits the installation of the grounding electrode conductor in the same raceway, cable, or armor as grounded service entrance conductors to prevent unwanted circulating currents and ensure proper grounding performance. By following these guidelines and consulting with qualified professionals, you can ensure a safe and reliable electrical system. The information provided is intended for educational purposes and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrician or qualified electrical engineer for any electrical work or design. In addition to the specific requirements of NEC 250.64e, it is also important to consider the general principles of grounding when designing and installing a grounding system. These principles include firstly, minimizing the impedance of the grounding path. The grounding path should have a low impedance to allow fault current to flow quickly and easily back to the source. Secondly, providing a direct path to ground. The grounding electrode conductor should be run as directly as possible to the grounding electrode, avoiding unnecessary bends or loops. Thirdly, bonding all metallic components. All metallic components that are likely to become energized, such as metal enclosures, conduit, and equipment frames, should be bonded together to create an equipotential plane. Fourthly, using appropriate grounding electrodes. The grounding electrode should be of a type and size that is appropriate for the specific application and soil conditions. Fifthly, inspecting and testing the grounding system regularly. The grounding system should be inspected and tested periodically to ensure that it is functioning properly. By following these general principles and adhering to the specific requirements of the NEC, you can ensure that your electrical system is properly grounded and protected from electrical hazards. Now, let's talk about the consequences of not following NEC 250.64e. If the grounding electrode conductor is installed in the same raceway as the grounded service entrance conductors, several problems can occur. Firstly, the grounding electrode conductor can become energized. This can create a shock hazard for anyone who comes into contact with the grounding electrode conductor or any metallic components that are connected to it. Secondly, the ground fault protection system may not function properly. The ground fault protection system is designed to detect and interrupt ground faults, which are unintentional electrical connections between a phase conductor and ground. If the grounding electrode conductor is carrying normal neutral current, it can mask the presence of a ground fault, preventing the ground fault protection system from operating. Thirdly, equipment damage can occur. Ground faults can cause significant damage to electrical equipment, such as transformers, motors, and generators. If the ground fault protection system does not operate properly, the equipment can be damaged beyond repair. Fourthly, fire can occur. Ground faults can generate significant heat, which can ignite flammable materials and cause a fire. For all of these reasons, it is essential to follow NEC 250.64e and ensure that the grounding electrode conductor is installed correctly. Failure to do so can have serious consequences. To further illustrate the importance of this code requirement, consider a scenario where a commercial building experiences a ground fault. The building's electrical system is not properly grounded, and the grounding electrode conductor is run in the same conduit as the grounded service entrance conductors. When the ground fault occurs, the fault current flows through the grounding electrode conductor and back to the source. However, because the grounding electrode conductor is carrying normal neutral current, the ground fault protection system does not detect the fault. As a result, the fault current continues to flow, causing a fire in the building's electrical panel. The fire spreads quickly, causing significant damage to the building and its contents. In this scenario, the failure to follow NEC 250.64e had devastating consequences. By properly installing the grounding electrode conductor, the ground fault protection system would have detected the fault and interrupted the current flow, preventing the fire. In addition to the safety implications, there are also legal and regulatory consequences for not following the NEC. Electrical inspectors are responsible for enforcing the NEC, and they can issue fines or require corrective action for any violations. In some cases, repeated violations of the NEC can result in the suspension or revocation of an electrical contractor's license. Therefore, it is important to take the NEC seriously and ensure that all electrical work is performed in accordance with its requirements. Now let's address some frequently asked questions about NEC 250.64e. One common question is whether the grounding electrode conductor can be installed in the same raceway as the equipment grounding conductor. The answer is yes. The equipment grounding conductor is a conductor that connects the non-current carrying metal parts of equipment to the grounding system. It is designed to provide a path for fault current to return to the source in the event of a ground fault. The equipment grounding conductor is not a grounded conductor, so it does not carry normal neutral current. Therefore, it is permitted to be installed in the same raceway as the grounding electrode conductor. Another common question is whether the grounding electrode conductor can be installed in the same raceway as the bonding jumper. The answer is yes. The bonding jumper is a conductor that connects two or more metallic components together to create an equipotential plane. Like the equipment grounding conductor, the bonding jumper is not a grounded conductor, so it does not carry normal neutral current. Therefore, it is permitted to be installed in the same raceway as the grounding electrode conductor. It is also important to note that NEC 250.64 only applies to the grounding electrode conductor for alternating current systems. The grounding requirements for direct current systems are different and are covered in other sections of the NEC. In conclusion, NEC 250.64 is a critical code requirement that must be followed to ensure a safe and reliable electrical system. By understanding the purpose of this rule and adhering to its requirements, you can help protect people and equipment from electrical hazards. Always consult with a qualified electrical professional for any electrical work or design, and never hesitate to ask questions if you are unsure about any aspect of the NEC. Electrical safety is everyone's responsibility, and it is important to take it seriously.